Okay, we're attempting this problem without making reference to the idea that this is really the hyperbolic cosine. We're not going to mention that. To use this formula, you have to know what F inverse is. This is sort of the standard derivation of what F inverse is right here. I'll let you look that over, but the idea is you follow the standard idea, interchange X and Y, including the X greater than 0, or on the interval from 0 to infinity, the range becomes Y greater than or equal to 0. And we end up with an equation that's quadratic in e to the y, using the quadratic formula on this, where a is 1, b is negative 2x, and c is 1. This is what you end up with. Okay, and then we take the natural log of both sides to solve for y, and there's F inverse. Okay, now if we took the derivative of this directly, we'd say the derivative of the natural log of anything is 1 over the anything times, chain rule, the derivative of the anything, and here's what we get. Of course, we could change the order around some of the terms, which we'll see over here. And now the idea is to show that if we use this formula to calculate the derivative of F inverse, we'll end up with the same thing that we got here. Okay, so to use this formula, we have to know what F prime is. Well, that's 1/2 e to the of the quantity e to the x minus e to the minus x, or you could put that all over 2. So using the formula, the derivative is 1 over F prime of F inverse. So here's where we put F inverse into the F prime function. 1/2 e to the, what do we replace this x with? The inverse function, ln of the quantity x plus the square root of x squared minus 1, minus a minus, what do we replace this x with? The inverse function, okay? And e to the ln of anything is the anything. I can put this 2 in the numerator, which I've done down here. E to the ln of this just gives us that. Minus, well, if we move this minus 1 up here, we can write that as 1 over x plus the square root of x squared minus 1, and that's why I've written this here. E to the ln of that is that. Multiplying numerator and denominator of the big fraction by x plus the square root of x squared minus 1 gives us this. Squaring this binomial gives us this right there. And if you combine similar terms, you get 2x squared plus 2x times that square root minus 2. You can factor out the 2, cancel the 2 in the numerator, and guess what? You get the same thing you get here when you find the derivative of the inverse function directly. There you go. Hope that helped. If you have any questions, post a comment.